Good morning. Today we will tell about the very important theme of crystallography. The name of theme, the symmetry elements of a crystalline polyhedron. The symmetrical figure or symmetric polyhedron is the figure that can be combined with itself as a result of symmetrical change. The reflections and rotations giving a polyhedron in combinations with itself are called transformations of symmetry or symmetric operations. The elements of symmetry are imaginary planes, lines, and points with the help of which reflections and rotations are made. To indicate symmetric transformations and the corresponding symmetry elements, there are used special conditional characters. All symmetry elements can be divided into groups. Look at the screen. The first group or elements of symmetry of the first kind: the plane of symmetry, the center of symmetry, rotational axis of symmetry. And the second group, elements of symmetry of the second kind, the inversion axis of symmetry. Let's tell about the plane of symmetry. The planes of symmetry is a plane that divides the figure in two parts located relative to each other as an object and its mirror reflection. Look at here, please. Here, the left side and the right side, this side and the other side, left hand and right hand, and etc. All of symmetry are strictly defined and all are intersected with each other. Look at this slide, please. You can see this point and at the same distance that point, and at the same distance that point. Here the same situation, and here A and A1, B1 and B, C and C1, and etc. A symmetrical transformation in the center of symmetry is a mirror reflection in the point. Each point of the figure is reflected in the center so that the figure rotates at the same time inside out. In general, the inverse parallelism is a characteristic feature of figure possessing of the center symmetry. Next element это rotatable axis or rotation axis of symmetry. The symmetry or symmetry axis. The symmetry axis is a straight line by turning around which at some particular angle a figure is combined with itself. The order of symmetry axis n indicates how many times the figure is combined with itself in a complete turn around this axis. The cube has 3 axes of 4th order, please, 6 axes of 2nd order here. Of course, you can see only some axes from all them, and 4 axes of the 3rd order that are cube diagonals here. And the number shows the order of symmetry axis. What is the order? Wait, have already thought about it, but I want to remember the order of symmetry axis n, for example 2, shows how many times the figure will fit itself with itself at full revolution around this axis. With this slide. Let's consider a polyhedron and his gnomospherical projection here. Let's rotate the polyhedron to 90 degrees. A four-sided prism here faces symmetrically fit together, but two of them gable roof here and here will not combine at the angle of 90 degrees to each other. This means that the polyhedron doesn't have the common axis of the fourth order. You can combine its face with another only by more complex transformations. Rotate the polyhedron to 90 degrees around its vertical axis and simultaneously reflect its faces in the center of symmetry. This is the symmetric transformation by an inversion axis of fourth order L4. This figure shows these transformations. Face R turns at 19 degrees in the upper hemisphere projections and reflected in the center of symmetry occupies the position of point B in the lower hemisphere. Thus, getting acquainted with the elements of symmetry, we conclude the outer apparent symmetry of the crystal is fully described by the symmetry elements, and the axis of symmetry of Ln and the inversion symmetry axis Ln minus. Here we see how to indicate the plane of symmetry M, the center of symmetry I, the ordinary axis of symmetry N, the second order 2, the third order 3, the fourth order 4, the sixth order 6, and inversion axis of symmetry N minus, the third 3 minus, the fourth 4 minus, the sixth 6 minus. And if you look the formal symmetry, the symbols are different. Plane P, center symmetry C, ordinary axis of symmetry L with N, and inversion axis of symmetry Ln minus. And now you can see the imagination of symmetry elements on the plane